This video, we're going to verify or learn how to verify if functions are indeed inverses of one another. Now, verifying is essentially just supporting your reasoning from the previous page's worth of work, okay? So now you're going to be given two functions, and you're either going to say yes, they're inverses because, or no, they're not inverses because. All right. So what you want to do is pick one function and change it or find the inverse of it if you are given an equation. Okay. I personally think g of x in this example is a little bit easier to work with. Okay. So again, g of x is really just y. Remember, inverses, all you do is change your x and y values. So I'm going to have x equals 2y plus 14. Goal is to get y by itself. Now, the way I do algebra is just do PEMDAS backwards. So I have multiplication, then addition, and well, addition is the last thing. So it's going to be the first thing I undo in this particular example. So I have x minus 14 equals 2y. And again, goal, still get y by itself. I have multiplication. The opposite of multiplication is division. So I divide the entire left side by 2. My 2's cancel, and I'm left with x over 2. 14 divided by 2 is 7, and it's a minus. So I'm left with x over 2 minus 7. And remember, I can put a 1 out in front. The way I have it written looks similar, but not exactly to what my answer choice is or what my given function is. So I'm going to verify it really quick. So I'm going to say y equals 1/2. So division. I hit the division button first, then I type my numbers. Arrow over, x minus 7, and I get a graph. And now, because I'm verifying that my answer, 1x over 2 minus 7, is the same as my f of x function, I want the graphs to overlap this time. So again, I have division, and I have 1x over 2, and then minus 7. And if you look, my green and purple graphs overlap. So therefore, I have indeed done this right. Another way you can do this is by looking at a table. So you type in your f of x function and you pull up a table, right? 3 points are the magic numbers. I like positive numbers. So 1, 2, and 3. When x is 1, I get negative 6.5. When x is 2, I get negative 6. And when x is 3, I get negative 5.5. I'm now going to close that graph off. I'm going to type g of x. So y equals 2x plus 14. Now, remember, all I do is I swap, or I should swap x and y. Okay, so I should see the points, negative 6.5, 1, negative 6, 2, negative 5.5, 3. So I'm going to pull up a table, and I'm going to type these new test points in the bottom and let Desmos evaluate it. for me. So negative 6.5, I get 1, so that checks out. Remember 3 points. Now, if this wouldn't have been 1, I would say no, they're not inverses. Negative 6, I get 2. So that works out. Negative 5.5 gives me 3. So that's also good. Okay. The last way is that you can do it by graphing. Right? And this green line is line y equals x. And again, if you want to do it by graphing, you would imagine folding this graph paper along this line, this green line, and it should make your blue graph and red graph overlap. This is probably the hardest thing for me to see, honestly, because I'm not a very visual kind of learner when it's with these graphs. So I prefer the table method. The reason I like the table method is because they're always going to give you 2 equations. Okay. Now, to do a couple examples, I'm going to do 12, 14, and 16. And again, I'm not even going to try doing it by algebra. Right? I'm just going to immediately go to Desmos. I'm going to say x, y. I'm going to go y equals, type my first equation. Now, even though the question may say verify by algebra, nobody is going to know how you solved it. The important thing is that you get the answer right. So again, I pick the points 1, 2, 3. 1 gives me 7. 2 gives me 8. 3 gives me 9. So that means if G is the inverse, I should have 7, 1, 8, 2, and 9, 3. So I'm going to erase that so I'm not looking at so much. I'm going to go y equals x minus 6. Pull up another table. Now I'm going to test these points. So 7, 1, that works. Remember, all 3 points must work. 8 gives me 2. And 9 gives me 3. So my response is going to be yes. F of x and g of x are inverses because x and y are swapped. This is your reasoning behind every single answer, okay? Unless you have a graph and then it's going to say reflected across the line y equals x or not reflected across the line y equals x. In that case, your answer is either yes reflected, no not reflected, okay? So negative 2, 5, I need 5, negative 2, so that works. Negative 1, 8 should be 8, negative 1. That works. 0, 11 is 11, 0. That works. 1, 14, 14, 1. That works. So again, my reasoning is the exact same. Yes, they're inverses because my x values and y values are swapped. Now, this problem, I have a graph, and again, I can't see the line y equals x, and and imagine the line as good as what some people can. So this is the line y equals x. So I know what the line y equals x looks like. But as far as saying these are reflected across it, like, I just don't know. All right, so what I'm going to do is actually find a couple of points. This right here looks like a good one. 2, 4, 6, 8, 0. So I know I must have the point 0.08 on the green graph. So 0, 2, 4, 6, 8. That works. I have this point, 4, 2. So I must have the point 2, 4. Well, 2, 4 is right here. And if you see it, it's not touching a graph. Okay. So my answer, or my response for this one is no, because not all x and y's values are swapped. I like to make a note, 4, 2 and 2, 4 is where I prove it wrong. Okay, so I'm going to come in here and actually highlight. So the purple was 8, 0. And I had green. 0.8 was good, but 2, 4 was not on a green graph. And again, once you get to 1 point, the answer choice is wrong. All right. If you have any questions, just let me know.